Hi, this is Arun Kumar P. I'm from Unit 4, Double Stub Matching. If a transmission line matching device is to be useful in range of different matching stations, it must have has many variable patterns or degree of freedom as a standing wave pattern. Since the pattern has two degree of freedoms, the SWR and the position of the first maximum, so we must the double stub matching. A single step of adjustable position and length will do the jobs very well at the frequency below the microwave range. This frequency range is rigidly defined, but it is commonly understood to occupy the spectrum from 1 to 100 GHz. It is also called broadly the centimeter range, since the two extreme frequency corresponds to wavelength of 30 and 0.3 centimeter respectively. At such high frequency, coaxial lines are employed instead of parallel wire lines, and difficulties with the screened slots are such that stubs of adjusted positions are not considered. To provide the second degree of freedom, a second step of adjustable position is added to the first one. This results in the double stub matching and is commonly used in for coaxial microwave lines. These two stubs are placed at 0.375 lambda apart, the lambda corresponding to the center frequency of the required range, since that appears to be the optimum separation. Two variables are provided and very good matching is possible. Not all loads can be matched under all conditions, since having a second variable stub is not quite as good as having a stub of adjustable position. Such a matcher is normally connected between the load and the main transmission line to ensure the shortest possible length of mismatch line. It naturally has the same characteristics impedance as a main line, and each step should have range of variation somewhat in excess of half a wave. The method of adjustment for matching is best described as guesstimation, trial and error, which may or may not be preceded by a preliminary calculation. When trial and error is used, the stub nearest to the load is set at a number of points along its range, and the farthest stub is racked back and forth over its entire range at each settling point of the first stub until the best possible match has been achieved. The SWR is of course monitored constantly while adjustment is taking place, unless the load is most unusual. For example, almost entirely reactive, it should be possible to reduce the SWR on the main line to below about 1.2 with this matchup.